Hello friends, welcome to all of you in Dr. Jaggi's Academy. In our previous we have discussed about the nature of matter. The continuation of the previous video, today we will discuss about the changes in the matter. So in this video we will discuss the four things. Number one is physical changes. Second one is chemical changes. Third one is kinetic molecular theory. And the fourth one is phase changes. So first of all we will discuss what are the physical and chemical changes. So physical changes, or we can say that the physical reactions. The physical changes are those changes in which the only physical state of a substance changes. Physical state means solid, liquid and gas. So those changes in which, for instance, liquid is converted to gas or solid is converted to liquid. So in these changes, there is no formation of the new substance. For instance, that is a boiling of water, in which that we have a water in a liquid state. On heating water, the water liquid state is converted into a vapor phase. So in this case, water is remain the same, but only state of the water that is changed. Initially we have a liquid state, water in a liquid state, and after the reaction, after the change, the water there exists in gas phase. So this is an example or best example of physical changes. The next one is what are the chemical changes? The chemical changes are those changes in which one substance is completely changed into the another one, and in which the new substances are formed. For instance, we have in our daily life, that is a photosynthesis, in which we have a carbon dioxide which combines with the water to form glucose and oxygen. So in this case, initially we have a carbon dioxide and water, and after the change, we get two new substances get, that glucose and oxygen. So this is an example of chemical change. The next example is burning of paper. Another one is the formation of water from the hydrogen and oxygen. So in this case we have initially hydrogen which combines with oxygen, and after the combination of both hydrogen and oxygen we get water. So these are the chemical changes. So let's start with another topic is kinetic molecular theory, which explain the behavior and arrangement of particles in the three states of matter, that is solid, liquid and gas. So what is the kinetic theory of gases? So we have some few points related to this theory. The main points are, number one is each matter is made up of a very small particles. So here we have a matter which contains a large number of small particles, and these particles, in between these particles there are large empty spaces. Here there is a large empty, means these particles are separated from each other by large distance. These particles, they are not stationary, they are in a constant motion, and on increasing the heat or on increasing the temperature, the motion of particle increases. According to the relation is kinetic is directly proportional to temperature, where K is the kinetic energy due to motion of the particle and T is the temperature of the matter. On increasing temperature, the kinetic energy is increasing, means motion of particle increases. And these are the main points of kinetic molecular theory or kinetic theory of gases. So on this theory we can discuss about the nature of three states of matter. What is the arrangement of particle in three states of matter, that is solid, liquid and gas. So in solid we generally have a particles are arranged in this spectrum. Means the particles are tightly packed and they arrange in a regular pattern. And due to their tightly packing of arrangement of particles, these particles, they can vibrate about its position, but they don't move past one another. So since the particles are arranged in a regular pattern, there is a strong attractive forces between these particles. Means these particles are held by strong attractive forces. So that is why the solid have fixed shape, the fixed volume, and they have a high melting and boiling point. So on increasing the temperature, when we heat the solid, the kinetic energy of these particles increases. As a result, they move past one another and they are converted into a liquid state at melting point. The second state of matter is liquid state, in which the arrangement of particles are like this. So it is clearly seen that the particles are not tightly packed. They are separated by the large distance. It means in between there is a large empty spaces. So due to a presence of large empty spaces, the particles are held by the less attractive forces. Means the particles can vibrate about its own position and they can move. They pass over one another. So due to presence of less attractive forces, that is why the liquid, they don't have a fixed shape, and that is why they have a low boiling point as compared to a solid. On increasing the temperature, when we heat the liquid, the particles, they are separated from one another and they are converted into a gaseous state at boiling point. So this is the arrangement and the behavior of particles in liquid state. The next one is the gases, in which the particles are arranged in this manner. It's clearly shown that the particles are very far away from one another. Means the particles are held by weak attractive forces. We can say it's almost negligible force of attraction between the gaseous particles. So due to a less force of attraction, there is a random motion of the particles. Means particles, they move in a various directions. So that is why the gases, they don't have a fixed shape and fixed volume. And when due to random motion of particles, the particles, they are collide with each other or they are collide with the side of container. So as a result, these particles exerts pressure. By relation is P is equal to F over A. Here P is the pressure of the particle on the container, on the walls of container. F is the force exerted by the particle and A means area. So this is the explanation of the nature and behavior of the particle in the gaseous state. So next we have a phase changes. What do you mean by phase changes? Phase changes means when the solid is converted into a liquid or liquid is converted, it means the physical state of the substance changed. So that is the phase changes. So we have a solid. On heating the solid is converted into liquid. On further heating liquid is converted into a gas. In the reverse traction, on cooling the gas, when the gas is cooled, means decrease the temperature, gas is converted into liquid, and on further cooling liquid is converted into a solid. Means on increasing the temperature, solid is first converted to liquid and liquid is converted to gas. Whereas on decreasing the temperature, the gas is converted into liquid and liquid is converted into. So these are the physical changes. The physical changes basically take place on increasing the temperature or on decreasing the temperature. So next we have a different physical processes. So basically during the physical change, solid is converted into liquid and liquid is converted to gas. The reverse reaction may also take place. So we have basically 4 different physical processes during this conversion. So first, when the solid is converted into a liquid, and this process is known as a fusion. The next, when liquid is converted to a gas, this is known as a vaporization. In the reverse traction, when the gas is converted to the liquid, this is known as condensation. And when the liquid is converted to the solid, this is known as solidification. So during the physical, we have when the solid is converted to liquid or liquid is converted to gas, basically 4 different processes take place. One is fusion, second is evaporation, third is condensation, and the last one is solidification. So next is the how does the physical conversion of the metal take place on changing the temperature. On changing temperature means on increasing the temperature or on decreasing the temperature. So we can say that what is the relationship between temperature and matter, the state of matter. So in the fusion, as we know that solid is converted into liquid. Solid means the particles are tightly packed. When they are converted into a liquid, the particles they move far away from each other. Means there are large empty spaces between the particles. The second process, which is known as solidification, in which the liquid is converted into solid. So liquid means particles are already separated from one another, but when they are converted into solid, the arrangement of the particle changes and they are tightly packed, and they are packed in a regular or irregular pattern. The third one is the vaporization, in which the liquid is converted into gases. So here we have particle in a liquid state. When it converted into gases, they are very far away from one another. Means there is a very less force of attraction between these particles. And the last one is a condensation, in which the gases is converted into a liquid. The gases means particles are very far away from each other. When they are converted into a liquid, they come closer a little bit. Means the empty spaces between the particles decreases during this conversion. So what is the effect of temperature? In the first process, which is known as a fusion, in which the fusion takes place only when the temperature increases. So why does the arrangement of particle take place on increasing the temperature? So when the temperature is increased, these particles in a solid state, they absorb energy. Means after absorbing energy, the kinetic energy of these particles increasing, and they are moved far away from one another. As a result, means the arrangement of particles, they are decreasing, means the particles are present in liquid state. So that is why this conversion takes place on increasing the temperature. In the opposite direction, when the liquid is converted into solid, which is known as solidification, in which this process takes place when the temperature decreases. So why does it take place? When the temperature decreasing, the particles come closer and the arrangement, they become regular. Means liquid is converted into solid. In the third part, evaporation is also take place when the temperature increasing. On increasing the temperature, particles absorb energy, they are far away from each other and converted into a gaseous state. In the last one, that is a condensation, the gases is converted to liquid. This also takes place when the temperature is decreasing. On decreasing the temperature, the particle they come closer, means the distance between the particle decreases. It means in initial state, the particles they are very far away from one another, but on decreasing the temperature, particles come closer, means thereby releasing heat. So due to increase of temperature and decrease of temperature, basically these processes take place, means fusion and evaporation take place only when the temperature is increasing, and solidification and condensation they take place when the temperature decreasing. Means on increasing or decreasing the temperature, the arrangement of particle changes. So that is why the physical state of the matter change. So this is all about the changes in the matter. And in the end of the video, I would like to thank to Sadar Jasbir Singh Patia, which is a director of Gobind Service School, Surrey, and Dr. Rishi Singh, the principal of Gobind Service School, for giving me support and motivation for making this video. So thank you.